Hi, my name is Joel Stacy, and my partner is Grace Lang. We are data consultants in the environmental industry, and this is a project on the impact of hybrid cars and wind turbines on yearly CO2 emissions. Increasing fossil fuel consumption has led to increased greenhouse gas concentrations, which not only impact global climate, but can also cause respiratory diseases as well as cancer. Hybrid vehicles and wind turbines have been an effective way to scale back on the amount of gasoline consumed and have seen a rise in the popularity and reliance. But are the impacts from these measures observable in the data trends for CO2 emissions? We set out to provide some insights. Three separate sources contributed to the data set. First, yearly CO2 emissions in the United States from 1960 to 2016 were gathered from worldbank.org. Hybrid car sales in the United States from 1991 to 2019 were also gathered from energy.gov. And finally, yearly wind turbine installations in the United States from 1981 to 2020 were gathered from doi.org. However, at this point in the project, our univariate analysis focuses on yearly CO2 emissions. We found that the CO2 data realization exhibits strong non-stationary traits with a root close to 1 on the unit circle. This wandering behavior can be seen in the plot of the data in the top left, paired with a zero frequency peak in the spectral density graph in the lower right. The autocorrelations gradually dampen to 0 as well, further indicating wandering behavior. The first model to fit to the data was an ARMA 1.1. This model was recommended according to both AIC and BIC minimization, and residuals for this model strongly exhibit the properties of white noise, which likely indicates that all the trends in the data have been captured by this model. The 5-year and 20-year forecasts for this model show a rebound in the CO2 emissions. Model performance was measured using AIC, ASE, and rolling ASE scores, and those numbers are displayed in the bottom right of the slide. The second model to fit the data was an ARIMA 0.11. An assumed D equals 1 component was factored out, and then an ARMA 0.1 was recommended through AIC minimization. The residuals for this model also strongly exhibit the properties of white noise. Metrics for the model are listed in the bottom right. Ultimately, we found that this model was better for predicting short-term forecasts, and that the ARMA 1.1 had both better long-term forecasting and overall performance. So far, we've only looked at the CO2 data. Our next steps are to include hybrid vehicles and wind turbines as explanatory variables. We will build a vector autoregressive model, a neural network, and finally an ensemble model in order to model the data and make forecasts. Thank you for watching. Feel free to reach out to myself or Grace if you have any questions.